Hello, greetings to all of you. So in this lecture we are going to discuss about solar energy. Particularly we are going to discuss about solar PV, that is solar photovoltaic. So solar is the ultimate renewable energy resources. This is for all the renewable energy resources. The ultimate source is solar. So what is solar energy? So we know it originates from sun with the thermonuclear fusion reaction happening in the sun. During this thermonuclear fusion reactions, the electromagnetic radiation is emitted. Okay, so this electromagnetic radiation consists of visible light, infrared and ultraviolet, X-rays and radio waves. So this radiated energy from the sun has powered the earth for many millions of years, and this is the ultimate source for all the fuels and all the energy resources that is available in the planet. Okay, now we will see some advantages and disadvantages of this solar energy. So the main advantage is all chemical and radioactive polluting byproducts of the thermonuclear reactions, that is we have discussed in the previous slide. So that all these radioactive polluting byproducts remain behind on the sun. Only the pure radiant energy is reached to the earth. Remaining things will not reach the earth. So energy reaching the earth is very vast. So for a calculation, for 30 days of sunshine striking on the earth, have the energy equivalent to the total of the planet's fossil fuel, both used and unused. So you can imagine the quantity what we have telling. So that is for only 1 month. That is equal to the overall, the total plant's fossil fuels that is used and unused quantity. So this is so much high. So what it means? Solar energy, the availability is also very high, and it is available in vast amount. Okay, so we have some disadvantages also. One of the main disadvantages is that reliability. So the sun does not shine consistently. Okay, for a single day, the sun emit the rays on the earth for maximum of 8 hours only. Okay, so morning 8 o'clock to evening 5:30, maximum of 6 o'clock we can receive the sun, the radiation from the sun in a huge amount. Other time it will be in minimum amount. Okay, so the solar energy is a diffuse source. To harness the solar energy, we need to concentrate into an amount and form that we can use such a heat and electricity. So the collection is a very complicated job in this solar energy. So this problem is approached by collection, conversion and storage. The first thing is collection. We need to set some regulated environment to collect the solar energy. It may be solar, the heat energy from the solar, or light energy from the solar. So the collection is here an important task. And conversion, how we are going to convert that heat energy from sun into electricity, or the light energy, that is the irradiation from the sun into electricity, is here an important thing. For converting heat energy into electricity, we are using solar thermal system, and for converting the light energy of sun into electricity, we are using solar photovoltaic systems. and the third thing is storage. It's a very difficult job to store the generated electricity through solar thermal or solar PV. So we need huge amount of battery package or capacitor bank to store this generated electricity. So these are all some major disadvantages of the solar energy. Now we already told that solar energy is converted into electricity through two different ways. The first one is solar thermal and the second one is solar photovoltaic. Okay, so initially we should have a collector system. We are having different types of collectors, flat plate collector, parabolic collector, concentrating collector and all. Okay, this flat plate collector, for this we are going to see how the solar energy is used to generate the heat energy. Okay, so this is the working principle of solar water heater also. Okay, so a flat plate collector is used to absorb the sun's energy to heat the water. Okay, so the setup is given in this figure. It has observer plate, and in the center we are having a transparent covers, and this system is set into inside a metal frame box, and inside that box we are having insulation. That insulation is used to reduce the wastage of heat energy, so it doesn't conduct the heat what we have generated. And we have tubes for liquid flow and plumbing fitting also. So through that tubes the liquid is applied. So from one side we are going to apply the cold liquid, and the heat energy from the sun is applied on that liquid inside the tubes, and the liquid inside the tubes will get heated, and we can get that thermal energy as a output. Okay, so for example, solar water heater, from one side of the tube we are going to apply the cool water, and another side of the tube we will receive the hot water. Okay, so the water circulates throughout the closed system due to the convection currents, and a storage tank is necessary to store the water. These are the working of solar thermal energy. Okay, so this is used in solar water heater. And another type is solar photovoltaics. So from the name itself we can easily identify solar photovoltaic, photo plus voltaic. So the light energy is directly converted into electricity, so that is solar photovoltaic. Okay, so we can see the solar panel in this figure, and the block diagram of this working principle is explained here. We are having a solar cell. In that solar cell we are having n-type layer. This is silicon based solar cell, boron enriched silicon based solar cell. We are having n layer and p layer, and there is a p-n junction. Okay, so the working principle is very simple. When the photon strikes on the solar panel, the photon means the irradiation from the sun. So the light energy from the sun is striked on the silicon boron enriched silicon layer of the solar panel. Okay, so what will happen means, at that time the electron will activated and it will move. Okay, so how we can get the electricity, how we can get the current means, During the movement of electron through a conductor, we can get the current. Okay, so we can get the current. That current is applied to the load. So plus and minus, we can get the DC current here. Okay, so I will explain this again. Now some background of this solar cell invention. In 1839, French physicist A.E. Becquerel has recognized the photovoltaic effect. In 1883, a solar cell has been fabricated by Charles Fritz, that is coated semiconductor selenium with an extremely thin layer of gold to form the junction. Okay, now we are using boron and silicon. During 1883, they have used selenium and gold, and then 1954 in Bell Laboratory they have experimented with semiconductor, and accidentally they have found out silicon doped with certain impurities was very sensitive to light. So from that photon, from the light energy, it reacts very well. So they have developed a silicon based solar cells, and it results with the energy conversion efficiency of 6%. Even though it is very low, during that time it has some unique results. Okay, so after that 4 years, 1958, the first spacecraft to use solar panels was US satellite Vanguard 1. This is the first satellite with solar panels. Yes, in early days these satellites with the solar panels have launched, and they have used very effectively in power generation also. And we already discussed this working principle of solar PV. Once again we will see the main part of the solar photovoltaic system is the solid state device, that is solar cell. Each and every solar panel having several cells that has been connected seriously. Okay, so we can explain this. It has anti-reflection coating. A solar panel has anti-reflection coating, so it get the intensity from the light energy from the sun without any reflection. It absorbs perfectly. Then there is a transparent adhesive inside the panel, and there is a outer layer cover glass is also available. So this front contact, the sunlight strikes on the panel, and inside that we are having two different types of semiconductors, that is N type and P type semiconductors, and there is a back conductor also, there is a PN layer also. Okay, so when the photon strikes on the silicon boron based solar cell, that means semiconductor N type and P type semiconductor, the electron will start to move, it gets excited, so it crosses the PN junction. Then what it means, when the electron movement is happen means definitely there will be a current. That current is conducted through a conductor or a wire. That current is transferred to a conductor or wire, so we can get the electricity. Yeah, here we see easily understood the working principle of the solar cells. Okay, the photon in the sunlight strikes the solar panel and are absorbed by the semiconducting materials to create electron and hole pairs. Okay, these negatively charged electrons are knocked to lose their own atoms and allowing them to follow through the material to produce the electricity. Here we can easily understood in this area. Okay, Now these are all some basic components. This look like many functional electronic devices, that is PN junction diode. The most important thing is solar cells, LED, diode lasers, photo detectors and transistors. Okay, let me discuss about the solar PV system. Okay, solar photovoltaic system, that is commonly referred to solar PV system, that converts sunlight directly into electricity. The working principle what we have discussed already. By following that working principle, the solar photovoltaic system works and it converts sunlight into electricity without any form of transformation. Directly we can get electricity. Oh, this is different to solar thermal collectors. For solar water heater, what we have discussed already. Okay, so a solar PV system can help reduce carbon emissions and your electricity bills by producing sustainable energy from the sun instead of burning the fossil fuels. So nowadays we are depending on fossil fuels based power generation. So more than 80% of our power generation is from fossil fuels. So the one and only and the successful alternate for this usage of fossil fuels is solar PV system. Okay, so most important thing, it doesn't reduce any GHG, greenhouse gases, though the carbon emission is very minimum or negligible. Okay, and we can see what is a solar cell, the structure of solar cell, and so much of cells have been arranged in series and parallel, that is known as PV module, and those modules are combined together to create the panel, and those panels are connected in series or parallel, means that can call it as array, solar array. So solar PV cell, solar PV module, solar PV panel and solar PV array. And the most important thing, what are all the types of solar PV system available? Okay, mainly there are two different types of solar PV systems. The first one is grid connected solar PV system and another one is off grid solar PV system. Okay, let us discuss about the grid connected solar PV system. In this grid connected solar PV system, the solar PV panels is there, grid connected inverter is there, and there is a meter that is connected with the utility grid, and another thing we are having the load. Okay, let me discuss. So the sunlight, the photon from the sunlight is applied on the solar PV panels. Okay, so by following the principle what we have discussed earlier, this solar panel is now going to generate the electricity. Okay, so what type of means DC. So DC in the form of DC. Now we are having a grid connected inverter. What is the purpose of inverter? Means it converts DC into AC. This symbol indicates DC and this symbol indicates AC. Okay, so it converts DC into AC. Then we can apply that AC into the AC loads. In our residential we are using maximum AC loads. Nowadays only very few using DC loads, but maximum we are using AC loads, so we need this inverter concept. Okay, the electricity DC generated from the solar panel is converted into AC through the inverter and it is applied to the AC loads. Another thing, if we are generating excess amount of electricity, means that electricity is applied to the utility grid through the meter. That meter is known as a net meter. In practical term we are called it as net meter. Okay, through the net meter we will transmit the excess amount of electricity to the grid. This meter will note down or record how much amount of electricity is applied to the grid. Okay, so this is one way of usage, and another one is panel, inverter, meter and grid. Okay, another thing, if this solar fails to generate electricity during midnight or after 6 o'clock also, we cannot be able to generate much amount of electricity. Okay, so at that time this load is satisfied through the supply from the grid. Okay, so during night time there is no sunlight, this system will not work. So this load needs electricity. The utility grid supply the electricity through the meter and the load. So this meter will record those data also, how much amount of electricity is applied to the grid, applied from the grid to the loads. That data is also recorded in the meter. Okay, so meter, that's why we are having two-way communication. From here also generated electricity to the grid during no generation, grid, meter, then AC load. Okay, so this is the structure of the grid connected solar PV system. Okay, now same thing with the battery package. Okay, now grid connected solar PV system with the batteries. Okay, here we are also having the same two principles. The first one is the solar PV system is here, solar PV panel is here, and the sunlight strikes on the panel, it generates DC, and that DC is converted into AC and it is applied to the AC load. This is one way of communication. Light, solar PV, DC to AC, AC to AC load. Okay, another thing, sunlight strikes on the panel, DC, that DC is stored in a battery. Okay, so in battery plus minus, so this DC current is stored, the DC in the form of DC, it is stored in the battery pack through the charger. We cannot able to connect directly to the battery. So through a charger only we can able to connect the panels, because there is so much of fluctuation is there. So as to charge the battery we need a charge controller or charger that is available in this same setup. So this is known as hybrid inverter / charger. Sunlight to panel, panel to DC, DC to AC and AC load, one way of communication. Another way is panel, sunlight to panel, panel to DC. So this DC is applied to the or stored inside the battery bank through the charger. Okay, and now during night time there is no sunlight, so there will be no communication here. Sunlight is no sunlight, PV panels doesn't work. Now the stored battery, the stored electricity inside the battery is utilized through the inverter and AC loads. This AC loads needs electricity during night time. So during night time this electricity stored inside the battery is withdrawn through the inverter. So that inverter converts the stored DC into AC and applied to the AC load, and this is a way of communication. And if we are having excess amount of electricity generations, mean we can apply that electricity through to the grid also. So this thing we already discussed in the previous slide. Okay, those things are very same. And if we need to use or utilize the electricity from the utility grid during the unavailability of solar panels, we can get it from this way: utility grid, net meter and AC loads. So the one and only extra component is battery bank only. Okay, the main difference is this battery bank, in the usage of this battery bank. In the previous slide, it doesn't any battery bank. So if the during the unavailability of the sunlight, the one and only possibility for this AC load to satisfy this AC load is through the grid. In this case, during the unavailability of the solar sunlight, the electricity stored inside the battery is utilized through the inverter to the AC load. After withdrawing the batteries to a very minimum or low level, it means discharge completely means we can get the electricity from the grid. Otherwise we can get the electricity from the stored battery, but these things will increase the overall cost. These battery panels, inverters, chargers, these are all having very minimum installation and maintenance cost, but this battery bank requires more amount of investment, maintenance cost, and it occupies more space also. So nowadays we are using this type of inverters, this type of solar PV system than the grid connected solar PV system. Okay, so nowadays we are having in our home, we are having this EB connection with the inverter. So the one and only excess thing is this solar PV setup. That setup we are having additional one change, that is solar UPS. In ordinary case we are using normal inverter. We are going to install solar panel means we can install them, and the electricity supplies through the solar UPS. Okay, so we can use the same battery bank what we have already available in our home. Okay, the next thing is off-grid solar PV system. Okay, there is no grid. You can generate electricity and you can use it. Okay, if you doesn't have any electricity means these AC loads will not be satisfied. Okay, during availability of sunlight or daytime, you can get the electricity and you can charge it in a battery bank. Okay, through the charge controller, the battery bank is charged and this DC is converted into AC through the off-grid inverter. This DC is converted into AC and it is applied to the AC load. This is the basic concept. Okay, suppose at night time there will be no sunlight, there is no need for this charge controller. The one and only package is this battery bank. So from the battery bank we can get the DC that is converted into AC and applied to the loads. Suppose we have withdrawn all the electricity inside the battery bank. The battery is low means we can't be able to satisfy the AC load. So this is the one of the main disadvantage of the off-grid solar PV system. Okay, and we can see some applications of this off-grid solar PV system. Water pumping, nowadays we can see in our areas. For agriculture we are using this type of solar panels and solar PV system, and in space, the very initial stage itself we have used this solar panels in the satellites and telecommunication system and solar home system. In every house we are having solar panels and we can generate our electricity by our own. these are some applications of grid connected system. For residential 2 to 8 kilowatt, for commercial buildings it is about 50 kilowatt, and solar plants or solar farms we are having more than 100 kilowatt. This is for commercial purposes. One of the huge amount of electricity means these types of this is very low, and this is somewhat high, and this is very high. This is applicable for solar power plants. And here we are having some data regarding the top 10 solar cell producers. Okay, so the main solar panel producer is Q-Cells Solar World from Germany, and the next in Sharp Visera Sharp Sanyo from Japan, Suntech from China, and Motec from Taiwan. These are all the top 4 solar panel distributors or producers in the world. You can see here the data. In future, what we will have means printable solar cells. So this is the organic cell, nanostructured cell. Okay, so this can generate the electricity. It can be printable in different colors. And now organic photovoltaics that converts sunlight into electrical power. Okay, so these are all some chemicals having the reactions with the photovoltaic effect. This is trans, polyacetylene, polythiophane, and polypyrrole. Okay, and nanotechnology solar cell design. The size is, you can see, 10 nm, 2, and this will be 10 mm, and this will be 300 nanometer. It's very minimum. These solar cells can be fabricated in this little size, and it can also generate electricity. Wherever it requires minimum amount of electricity for operation, we can use this nanotechnology based solar cells. And the final thing, synthesized solar cells. Okay, so it can be printed in our shirts also. There is a dye synthesis means if we have designed something or wrote something in our t-shirt means it can generate electricity. So that dye itself we can generate electricity. Those dye, those chemicals TiO2, titanium oxide can generate the electricity by following the solar photovoltaic effect. That is, photons strikes on that effect means this electron will move. The movement of electron is this movement of electrons through a conductor means we can get the electricity. So thank you very much.